All right, simplifying radical expressions. I know this doesn't say notes on it, so let's just write notes so we don't get confused. All right, simplify the square root of a squared. Well, think about it. What is a squared?
2a.
So it's really like saying the square root of a times a, right? Which means it's a. Simple enough, just abstract. Okay, that's what algebra is. It's putting abstractness to things that you actually will use. All right, so a cubed. Well, that's like saying a times a times a. All right, when you have a pair, you can pull it out. All right, we've been doing this. So I'm pulling it out. That's what we did yesterday, and I'm left with 1a inside. Okay? All right, here we go. A to the fourth. So it's like saying a times a times a times a. I have one pair. I have two pairs. So I can pull out two a's, which is a times a, which is actually a squared. Okay? A to the fifth. Oh my goodness, I know this is just going on way too much. A times a times a times a times a. So I have one pair, so I can pull out one a. I have two pairs, I can pull out two a's. So that would leave me like a to the first times a to the first. I'll show you that. And then the square root of a is left inside, and a to the first times a to the first. Remember your laws of exponents? What do? Add them. Yes. So 1 plus 1 gives you a squared times the square root of a. Simple enough? Okay, a to the sixth. Here we go. A times a times a times a times a times a. I'm just showing you. You've got the long way, okay? Actually, what you could do is just take your 6 and divide it by 2, and now you know that it is a to the third. Okay? All right, a to the seventh. So if I take, how many pairs can I take out of 7 a's?
3.
3 pairs. So I think we can stop with this and do a to the third, and I'd have 1a left in. Does that make sense? Okay? So I guess I want to put a little note here that says, always simplify what is outside the, and what did we call this sign yesterday? The radical sign. So you always want to simplify what's outside the radical sign, and also if you have anything that you're multiplying inside the radical sign also. Do you see a pattern in the exponents? And I kind of already gave that pattern away. What is it? Even powers, we'll put it in some better terms, okay, are perfect squares and are divisible by 2. So just divide by 2 to take out of the radical sign. Okay? So your exponents is what I'm talking about, are the perfect squares, not the a or the whatever. I'm talking about your exponents. If you have even powers, even exponents, they're considered perfect squares, and therefore you can just divide by 2 to take out underneath the radical sign. Odd powers divide by 2, those come outside the radical sign, then 1 remains inside the radical sign, okay? Because odds are only 1 away from evens. Doesn't that make sense? Right? So, a to the 24th, it's even. All you got to do is 24 divided by 2, and what do you get? 12. Even, so a to the 12th. It's that simple when it's just this. Okay? Of course, you know life is never going to be this simple, though. A to the 40th is, I'm waiting. A to the 20th. A to the 120th is going to give me a to the 60th outside the radical sign. And we'd have nothing left inside. So when you have a to the 31st, you take 31 and you divide it by 2, and you find out that that is 15, isn't it? And then you would have how much left over? You'd have 1 left over. So you have a to the 15th to the times a, or a to the 1st. Well, you get 15.5, which means that you have 1 left over, okay? So you would have 1 left over, and you kind of have to look that abstractly, but if you take 31 divided by 2, you're going to get 15.5. Well, 15 of them are pairs, okay? All right. So, a to the 47th, what's that? A to the power of 23 times the square root of a. Because when you take 47 and divide it by 2, you're going to find out it's 23.5. Okay? A to the 101. A to the 50th times the square root of a. So it's pretty simple when there's just one variable and just one little, when there's one variable inside the radical sign, it's very, very simple. When there's no numbers, no nothing, pretty simple. But, life can't be that easy, right? Because life is difficult. It just is, okay? You just got to get used to life being difficult. So, what do I have here? I have 144, and I have the square root of 144 y squared. Well, this really, I can look at this as the square root of 144 times the square root of y squared. Okay? So what's the square root of 144? 12. So now that I have a number here, I'm going to do plus or minus 12. And what's the square root of y squared? Y. And I'm done. Okay? 14. Ooh, look at this. I've got the square root of 81 times the square root of a to the 4th times the square root of b to the 6th times the square root of c to the 10th. Okay? Well, the square root of 81 is 9 times a to the 4th is going, what am I going to be able to bring out? 4 divided by 2 is a squared, a2, times, I got 6. So here I've got 6 divided by 2, which is b to the 3rd. And then 10 divided by 2 is c to the 5th. Now these are going to get very complicated. So my suggestion is that once you pull out, and I'm going to set you up with a pattern that I want you to use, but you start crossing off what you've done and what you haven't done, because these are very, very simple. So if I came up here, I would write my answers plus or minus 9a squared b to the 3rd c to the 5th. Okay? And I will set you up with a pattern as they get more complicated and help you out. Okay? All right, so here we go. And it starts. I'm going to say this is the square root of 24 times the square root of x to the 5th. Well, 24 is not a perfect square. So I'm going to come over here and I'm going to prime factor it like we did yesterday. 24 divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. So on the outside, and what I do here is I go ahead and put a radical sign over here. Okay? I can take this pair out of the radical sign, and I can put a 2 on the outside, can't I? But I have to leave these things inside. So 2 times 3 stays inside. I've dealt with 24. I'm crossing it off. Now I've got x to the 5th. Well, we know that 5 divided by 2 is 2.5. So now I know that I can take 2 of those out. So I've got 2 times x squared. And if I take 2 of those out, I'm leaving times x to the 1st in here. Okay? And I would go ahead and indicate those first, those seconds, because believe me, it's going to get a lot more complicated. Okay? So now I can do this and clean it all up. 2 times x squared is plus or minus 2x squared times the square root of 2 times 3 is 6. And x to the 1, I'm not doing anything with it, so I can just write it as x. And that's my answer. Simple enough so far, huh? Okay. All right. So here I'm going to set myself up. I'm no longer really going to write this all out. Okay. It's just who I am. I'm crazy. So, and I think you guys are pretty smart that I shouldn't. Well, I'll do it one more time. 75 times x squared times y to the 3rd. Okay. So I'm going to deal with my 75. It's not a perfect square, so therefore I'm going to have to do prime factorization just like we did yesterday. 75. Let's see. 2 doesn't go into 75. Does 3 go into 75? Why, yes. 3 goes into 75 25 times. Then I go, oh, 2 doesn't, 3 doesn't, 4 doesn't, oh, 5 does. And actually, that's a perfect square, isn't it? So it's 5 and 5. So now I know I can pull out 1 5, can't I? So I've got that. I'm going to write that here. I'm going to put my radical sign over here. I forgot to do that at first. So I've got what left over? 3. So I'm going to put that underneath. I've dealt with my 75. X squared. What can I pull out? An x. Okay, times x. So that's dealt with. Y to the 3rd, what can I pull out? Y squared, so that's really y, right? Because 3 divided by 2 is 1.5, so I can pull 1 pair out. Think of it that way always. It's how many pairs can I pull out of y? And if you had to, you could sit here and say y times y times y, so that you're visually seeing I'm pulling 1 pair out. I've got a y, and that leaves me 1 y underneath. All right, to clean this up, I'm just going to write 5 plus or minus, 5xy to the square root of 3y times the square root of 3y. Okay? Oh, look at this. It's getting fun. Oh, I love this. This is so much fun. It really is. Okay? And this is not even the worst of it. This is just way too much fun. Okay? So I already have some things on the outside, don't I? Okay? Nothing I can clean up out there. It's all pretty. So I'm going to go ahead and write those. A squared times b. I've taken care of those. They're in my list. And I'm going to put b to the 1st. Because remember, when we get to exponents and we're multiplying, you're actually adding. So it's really important to write that b to the 1st. Okay? Now I've got to deal with what's underneath. I'm going to deal with that 162. So 162 is not a perfect square. I know that. If you don't, you need to know them, okay? So I can take this and I can do 2. 2 goes into 16 8 times, goes into 2 1 time. Ooh, now I know I can do 2 doesn't do it, but 3 will. And I've got 27. And 3 goes into that, and I've got 7. No, 3 times 9. So sorry. And that would be 3 and 3. Now, if I knew 81 was a perfect square, I could have put my 9. But the problem is then you have to recognize what you're pulling out, okay? Because if I had done that, which is not a big deal, I'll do it on this little card here. I could have done 162 divided by 2, and I get 81. If I know that 81 is a perfect square, what am I pulling out? 1 9, correct? Because I have a pair of 9s. All right, you can go there. All right, if you know it, that's great. If you don't, then I've got a pair of 3s. I can pull 1 out of that, and I can pull 1 out here. So how many 3s am I pulling out? 2 3s. So I can do times 3 times 3, which 3 times 3 is going to give me what? 9. Okay? So you see it could have worked either way. All right? So now I've dealt with my 162. Now I have an a to the first. Oh, I didn't write my little radical sign over here. Can I do anything with that a to the first? I can't pull anything out, so I still have a to the first. All right? Cross that out. B to the 6. 6 divided by 2 is what?
3.
What?
Why didn't you put your 2
Yeah, that's not how to think.
in the right?
Ooh. Oh, thank you. Oh, thank you so much. Yes, I had a 2 left over. I should have crossed these out. That's better for me. 2, and then I have times a to the first. Okay? All right. Thank you for catching me, John. All right? So then I've got b to the 6. What can I do? I can take out 3 of them because 6 divided by 2 is 3. So times b to the 3rd. Taking care of my b. What about my c? 5 divided by 2 is 2.5. So I can take out 2. C squared, and that leaves me 1c to the first power in here. Okay, now I've got everything. Now I need to clean it up. The first thing you need to know, numerals always come first. Okay, always. Just that's the way it is. So plus or minus, I'm going to look along here and see what I can do. Okay, I got 3 times 3, which is 9. I'm crossing them off. You see? Very methodically crossing them off because it will get tricky. Now I've got, remember in order, A comes before B, okay? Z comes before nothing, all right? So remember you want it in alpha, all right? And alpha first, then numeric, okay? So I've got my numeral, then alpha is my a's. Do I have anything to go with my a here? No, not on the outside. So I'm going to cross it off and I'm going to write a squared. B, what have I got? Damien, it's exponents. B to the 4th, because when your exponent laws say when you have exponents, you add them. The only time you multiply them is if you had something like that. Then you would get, that would equal b to the 9th. All right? But if you have b to the 3rd times b to the 3rd, it is b to the 6th. All right? You got to follow your exponent rules. So I have 3 plus 1 is 4, so I'm going to put b to the 4th. I'm going to cross my b's off. Now I've got c squared. Can I do anything with that? No. So I've got c squared. Now I got to figure out what's going on inside. So here's my square root symbol. 2 doesn't multiply times anything, so I've got 2. A to the first doesn't have anything to go with it. C to the first doesn't have anything to go with it. And that is my final answer. Puzzles. I keep saying algebra is puzzles. You gotta love puzzles. All right, here we go. 3. mn squared to the square root of 121. M to the 4th, n to the 5th, p to the 7th. Woo! Sounds like fun to me. All right, I know that I got a 3 out here. I've got an m to the first out here. I've got an n squared out here. What? Can you what? Okay, I'm sorry. And now I've dealt with that, and that. So now I'm going to do my 121. Okay? 121 is a perfect square. How many of you know that? Yay! Okay? So, if I sat here, I could sit here. Will 1 go into 121? 2 go into 121? 3 go into 121? 4 go into 121? 5 go into 121? I would sit here and go through the whole thing until I figured out it was 11. Okay? So, 11, and the only reason I know that 11 is the only thing that will go into it is because 11 is prime. Okay? There's nothing that will go into 11, will there? Is there? So I have, what do I have? A pair of 11s. Yay! So I can put times 11. I've dealt with my 121. Oh, I forgot to put my radical sign over here. Here we go again. All right, m to the 4th. What can I pull out? How many? 2 times m squared. Dealt with my m. N to the 5th. How many can I pull out? 2 times n squared, and that leaves me 1n to the first inside. Cross that out. P to the 7th. How many can I pull out? Times p to the 3rd, and that leaves me times p to the 1st. Okay? Alrighty. Well, I said do plus or minus, do your numerals first. So 3 times 11 is 33. Dealt with that, dealt with that. Okay. Now I've got m. I've got how many m's in all? 3. 1 plus 2, so that's 3 m's. Then how many n's? 2 plus 2 is 4. And how many p's? 3. And then clean up what's inside. I'm just going to make it NP. It's not so bad, is it? Not until you get fractions. Oh, and I don't have any examples of fractions. Isn't that sad? Isn't that sad? And there's none on here either. Oh, but there is one on your review. Because there is one on your test. Oh.
There's one on the test.
Oh. How did I miss putting one? I didn't put one on here, but I put one on your test. Aren't I mean?
Yes, that's very mean.
I'm so mean. Yes, I am. Yes, I am. Okay, let's see what we got here. Okay. Look at this negative sign out here. Is it going to matter? No, because when you pull that out, you're going to put plus or minus anyways. Okay. So we're just going to ignore what we got going on there. Okay. And you'll see why. All right, so I've got 5 times x to the first times y to the first. Okay? Took care of all that. Next, 72. I'm going to start with my 2. 2 goes into there 36 times. 2 goes into there 18 times. 2,
perfect square.
oh, it was. Goes into there 9 times. 3 goes into there 3 times. So sorry I missed that, but we're just going to do this. 2 times 2, 3 times 3. I can pull 1, 2, 1, 3 out. So times 2 times 3. That leaves me underneath my radical sign a nice 2. Okay, so I've dealt with the 72. X to the 5th. 2 goes into 5 2.5 times, so I can pull x squared and leave an x in. Done my x's. 4 divided by 2 is y squared. No y's left in. Now I need to clean it up. 5 times 2 times 3. See, and if these were plus or minuses, see, it wouldn't matter because it would change every time, okay? So 5 times 2 is 10. 10 times 3 is 30. X to the first, x to the second is x to the third. Y to the first, y to the second is y to the third. Now clean up and I've got times 2x. Okay? Not that bad, right? If you follow the pattern and don't try and skip steps, you'll get it right every time. If you try and skip steps, you will get it wrong, and that's what I am predicting. Now, let's try one just for the fun of it. Just for the fun of it. Let's see. What was that little booger on your review? I don't think I have any extra copies of the review this time. Here, can I see it?
You talking about this one?
A little booger on your review.
Yeah, because I saw it like.
Alright. And this one doesn't have any variables. The one on your test even has variables, so you're not going to like me even more. Okay? Alright. I'll warn you now. The square root of 136 over 16. Okay? Alright, so this is number 8 on your review, but I'm telling you, the one on the test even has variables. Okay? I thought for some reason I gave out something that was more complicated. I guess not. I'll look at the one on the test and make sure I'm not killing you on the test. Okay? Alright. So you can look at this in a couple of different ways. You can look at this as the square root of 136 over the square root of 16. Okay, that's the easiest way for me to look at it. I already know what the square root of 16 is. Do you? What is it? 4. So I can say that I am going to have a 4 here. Or I could look at it and I could come over here and I could do 16 and I would get 2 and that would give me 8 and 2 and that would give me 4 and then I'd have 2 and 2, wouldn't I? So I could sit here and do, okay, I've got 2 pairs of 2's, which is 2 times 2. So I could list this as either this, and I'm going to show you both ways, or I could have it 2 times 2 underneath. Okay? All right, if I'd pulled my 2 pairs out and done it the long way, then I'd have 2 times 2, which is obviously equal to 4. Okay? 136 is a little more complicated. 136, I'm going to divide that by 2. And I find that 2 goes into there 68 times. So then I have another 2. And now I have 34. And I could do another 2. And that would give me 17. And 17 is prime, so I have to stop there. Okay? Well, so I could pull one pair of 2's out, couldn't I? Okay, so if I have that, I'm going to put my, this is a plus or minus sign, obviously, but I have a 2, okay, and I could put my 2 here. And then underneath, I have 2 times 17, don't I? 2 times 17, okay? Now, this is not simplified, okay? Even if it says 2 over 4, it is not simplified, all right? You've got to get it to the point where that's where this, it's more noticeable, but 2 goes into itself how many times? Once, okay? So I could look at it, and 2 goes into 4 how many times? 2, right? And then 2 times 17 is 34. So I could look at it like that, or I can just look at it as the square root of 34 over 2. Okay? I could I could do that. Here, it looks more obvious. You're just taking this and you're taking this and you're canceling each other out. And you've got the square root of 34 over 2. And that would be the simplified answer. But remember, anytime you have a fraction, you have 1 on top. Okay? But most of the time, it's just like I keep saying, we're lazy mathematicians. We're not going to write that 1. You just have to remember that it's there. Okay? Because if I had to manipulate this equation somehow, I could multiply both sides by 2, and now I would get rid of that fraction. I could multiply this by 2 and get rid of that fraction, correct? As long as I had something over here that I could manipulate. Like if it said a is equal to 1/2, then I'd have 2a is equal to the square root of 34. Do you see that? That's literal equations, which we're doing again tomorrow. Okay? So, you just have to remember that in a fraction. And what I'm trying to say, and I know this is crazy thoughts, but if I had 34, the square root of 34 over 2 is equal to a, and I was trying to solve some formula, and I needed to get rid of my fraction for some reason, I could always take this side and multiply it by 2 over 1. Take this side. What I do on one side, I have to do on the other side. And I would end up with 2a is equal to the square root of 34 because this would cancel this out. Do you see that? And this is a 1 really. So it's just a thought that, I know fractions are my friend and they're trying to become your friend.